Hi everyone. So far we have covered that why you want to solve system of linear equation, what is the geometric interpretation of that, and most importantly, we have understood Ax equal to b intuitively, which means now we know intuitively what does Ax equal to b means, which means that Ax is nothing but a linear combination of columns of A, and if b is also a linear combination of columns of A, then we have a solution for x. Otherwise, we don't have a solution. And few other things we have understood very intuitively, right? Now let's go to the bigger part of the story, which is that is understanding or solving this Ax equal to b step by step, which means now we are yet to cover that how to solve this Ax equal to b step by step. And main important component of this part is Gaussian elimination. So let's just understand this. But before that, let's just see a quick recap so far. So what we have covered, right? So we started with that what is linearly dependent, what is linearly independent. So we say the vectors v1 to vk are linearly dependent if and only if there is at least one vector that can be written in form of others. So this is the definition that we had in words, but let's just see the same definition mathematically. So we say that there is an equation, which equation looks like this. If you have in this equation, if you have ci which is non-zero, if there is just a non-zero ci, it means you can represent vi, at least vi, which is a vector vi, in terms of other vectors, then they are linearly dependent. Otherwise, they are linearly independent. That's what we said. So given that set of vectors are linearly independent and we have this equation, it means that all ci's are zero. Okay, which means if they give you this equation and they also say that all the vectors are linearly independent, it must mean that all ci's are zero. That's the only case when you can satisfy this particular condition. Okay, now I hope now you understood that what is linearly independent and dependent, right? You must have understood this. Now we talked about filling the space. We say that these are the vectors in some space Rn. So you don't need to worry about what is this space and all. Like we call these R2, R3, R5, R4 or these things just a vector space or a space. Okay, so you don't need to worry about these particularly. Now we are saying that this v1 to vn, we fill like these set of vectors will fill space Rn if these vectors are linearly independent. So to fill space Rn, you need n linearly independent vectors. And then we said that these three vectors can fill R3 and these three vectors are just convenient vectors to us. So these three vectors we say are just convenient vectors to us, which means that there is nothing special about these vectors. I mean, if you ask me whether these vectors are special to me, I will say that for our purpose, nothing speciality about these vectors, but only that these vectors are convenient in the sense that I do not need to do too much of calculation. Actually, this is just 1 and 0 and I can do the calculation very easily, which means if I want to represent any vector, let's suppose 2, 3, 9, in the linear combination of these three vectors, then finding the coefficients are very convenient to me, right? You know the whole story that how to find the coefficients of this. So this is how you can directly write the coefficients, and which are also called coordinate systems, right? I mean, these are also called coordinate in our coordinate system. Anyway, these are just convenient vector that I wanted to convey. Now then we have seen that how to multiply a matrix and a vector. So then we came to know that this Ax, this is just a linear combination of columns of A. And we are saying that Ax equal to 0 is having a non-trivial solution. Then I mean, we have seen some examples or some question where we talked about this, that it has some non-trivial solution. Then what does this mean about the columns, which means whether the columns of A are linearly dependent or independent. We have solved these kind of questions, right? If B is a linear combination of columns of A, then Ax equal to B have the solution. So we have solved these kind of questions or examples, you can say. We have done it. Now then we talked about one thing where we are saying that, see, if you have a vector that can be represented as a linear combination of other vectors, let's suppose these three vectors, where V is a linear combination of these three vectors, then I say that if these three vectors are linearly dependent, then there are many such solutions, which means if you want to represent this vector as a linear combination of other vectors, and if these vectors are linearly dependent, then there are many such ways to represent it. Otherwise, there is only just one way, right? If they are linearly independent, then there is exactly one combination. Okay, if you can represent, then there is only one combination. If they are linearly independent, if they are dependent, then many combinations, right? Okay, so that's what we have seen. Now you came to know that, okay, the equation that we are solving, or the set of equations we are solving, which is Ax equal to 0 or Ax equal to B, the relation between these two, like what is the relation between this thing, and we have seen linearly independent and linearly dependent vectors definition. which means how this definition of linearly dependent and independent and Ax equal to b are related. So there is one thing which is relating these two, and what is that thing? Can you just tell me? That thing is multiply a and vector, right? A matrix, I mean, you can say multiply a matrix and a vector. So when you came to know that how to multiply a matrix and a vector, then you came to know that, okay, this Ax equal to b is, or in fact this Ax is just a linear combination of columns of A. And then you talked about the columns of A linearly dependent are linearly independent. And then this definition and this definition got, this particular thing and the definition of linearly independent and linearly dependent got very much connected. Once you understand this, how to multiply a matrix and a vector, things become very easy in X equal to b. But today we will see systematically, or I can say that a step-by-step method to find the solution for X equal to b. So now we are going, or the heading towards a step-by-step method to find the solution for X equal to b. So now we will be solving Ax equal to 0 and Ax equal to b, and I can say step by step, okay, which means there is a procedure that will do it step by step. So this is basically completely mathematical. Yeah, there will be an intuition behind everything. So I will convey the mathematics and the intuition also. But before that, let's just see that if you are given a system of linear equation in your high school, then how to solve it? I mean, how you used to solve it in your high school. Let's just see. Okay. So we are solving the system of linear equation using the high school way. So what we used to do, let's suppose these two equations are given to us. Then if I ask you that how you eliminate this x completely from second equation, then what you will do? So I mean earlier, if you remember your high school days, then what you used to do, you take these two equations, right? You take these two equations, you write these two equations, you eliminate one of them. So maybe you multiply by 3 here, and then it will be like, let me write here. So it will be basically 6 and this will be 3, right? So you can write these coefficients. It will be 3, it will be 6, and then this will be 3. And then you do one thing, you do subtraction here, if you remember it. Otherwise it is fine, like we are going to see other way. But yeah, you subtract both of these equations, and then finally you get -9, right? That is how you used to solve. And then you get the value of y, and then you put the value of y here, and you get the value of x. So that is how you used to solve, which is 9 by 8, I think. Sorry, this is 8. So y is just 1, right? This is 8, and hence y is just 1. So this is how we used to solve in our high school. So what we did, you just need to observe here. We have eliminated, so what we did basically, we have eliminated x from here, and we got this equation. I mean, you can say you eliminated x from here, or maybe x from here, doesn't matter. So basically out of these two equations, what you did something, and then you finally figured out that there is an equation which is looking something like this. And from this equation, you got the value of y, and you are putting the value of y in one of this equation, right? So basically, if you just understand that what we are doing, out of these two equations, we are just considering, we are just, I can say just figuring out that another equation which is looking something like this. So what we are going to do, once we have these two equations, we will write one more equation, and then we will use this equation which we have just got from these two equations, and out of these two, we will just use one of them, right? So essentially what we are doing, out of these two equations, I am saying that one of the equation for me is just useless. Okay, I mean, see, out of these two equations, I will be getting first this equation, and then I will say that I started. Okay, see, I will say that I started with these two equations, but ultimately I got one more equation, which is something like this, right? And yeah, from this equation, I'm getting the value of y, that is fine. But out of these two equations, I have got this equation. Then I'm saying that once I get the value of y, and then I will just forget about one forget about one of this equation. I will just make use of only one equation. So let me just say that I will forget about the second equation. So basically, what I'm saying here is that you have these two equations, you got this equation, and then you will just make use of one of this equation. Maybe let's suppose you are just making use of this equation, right? So from here, from these two equations, you are getting the value of x and value of y, isn't it? You started with these two equations, you are getting this equation, and you are just using one of them. You can take any one of them. I don't have any personal opinion that you take this one or this one. You take any one of them, and then you are saying that out of these two you are getting the value of x and y, right? Okay, let's just do more practice and then you will get to understand. So basically you get this y, and then you put the value of y in one of this, and then you get the answer. So out of these two we got these two equations. That's what I mean to say, right? I mean, out of these two we actually get only this equation, but I'm just forgetting about one of the equation. You can just forget about any one of the equation. I mean, you just put the value of y in any one of the equation, and then you get the final answer. Let's just do this question. Now what you need to do, you need to eliminate x from just one of the equation, maybe the second one or third or the first one. So let's just do it, right? So to eliminate this x, what we can do, we can multiply 3 here. This will be 12x minus 24y equal to 12. This will be, if you multiply 4 here, it will be 12x plus 8y equal to 44, and then you can subtract one from each other. You subtract this, and then you subtract this, then it will be minus 32y equal to, it will be minus this is 32, yeah, this is also 32, and then finally you get y value is 1. So now you put this y value in one of this equation, right? So that's what we are doing. We are basically starting with these two equations, we are getting one equation, and then from this equation we are just putting the value back in just one of the equation. So see here, we are starting with these two equations. Out of these two equations we are getting this equation, and then we are making use of one of this equation, maybe this one, right? So these two equations we are making use, and ultimately we are saying that we are starting with these two equations, and then we got these two equations. So this is just a simplified version of these two equations only. So whatever we have started with, that's the same thing. It is just a simplified version of this, right? So instead of the second equation, I just write this equation. That's the only difference. And then I get the value of x and y. How? You get the value of y, that is 1, and you put the value of y here. 4x minus 8 into 1 is 8 equal to 4, and then you get the value of x, that will be, I think, 3, right? So that's how you can solve this question very easily. Now let's just try solving this question. If there are 3 equations, then what you will do? Probably this is little tricky, but still let's just try doing it. These are the 3 equations and 3 unknowns. So you will be just eliminating, let's suppose, x and y from here, or maybe something like this. You will be doing some operation. So let's just try finding out the value of x, y, z using the earlier method. So what we can do, we can basically eliminate this x here. It seems that we can easily eliminate this x here by just adding out these two things. So which means that you can say that you can write, or maybe I have the steps on the next page. The step 1 is basically subtract 2 times equation 1 from equation 2. Okay, so you can subtract 2 times equation 1 from equation 2, which means you can subtract 2 times of this, and then maybe add equation 1 and 3. So you can add these two. So finally I think I have the result here. So basically what we can do, we can get out of these 3 equations, we can get these 3 equations, okay, by the simplification. How we are simplifying? The written steps are here. You just add these two, then if you add these two, it will be 0, like third equation will be 0, it will be minus y, it will be minus 5z and equal to 12. So you just see here, like this is, yeah, y plus 5z equal to minus 12, y plus, okay, this is, if you add these two, yes, sorry, these are the plus. If you add these two, then these are the plus. If you add these two, this one and this one, then you will get y plus 5z equal to 12. So y plus 5z equal to 12. And similarly, if you do this operation, which means if you subtract 2 times of this from this equation, then you will be getting whatever it is written here, which is y plus z equal to 4. So basically you get these 3 equations, and then what you can do, you can get now the value of y and z from this, and then you put the value of y and z from in this, and then you get the value of x. So basically you can do all of this, and then this set of equation becomes this, okay, and then you take the value of z from here, you put the value of z in this, and then you get the value of y from here, and then you put the value of y and z in this, and then you get the value of x from here. So basically this is our goal, and yes, we did it, right? So actually, if you have not understood that what we are doing, actually, like, I don't want to explain it more, because the reason being is that there is a systematic way, and we will follow the systematic way, okay, don't worry. But I just wanted to introduce the complexity that is here if you do not follow the systematic way. Which means if these are just 2 equations, then okay, that's fine. But if these are the 3 equations, then there is a little bit of juggle, right? So what you can do, if you have more than 3 equations, I mean, what you will do if you have more than 3 equations, which means that what if there are 10 equations? What if there are 20 equations? What if there are 100 equations? What if there are 1000 equations? How you will solve 1000 equations just like this? You will go mad, right? I mean, you cannot solve just like this. So there has to be some systematic answer. The answer is Gaussian elimination. So according to Wikipedia, as you can see here, according to Wikipedia, like I have taken this statement from Wikipedia, it is an algorithm to solve system of linear equations systematically. Algorithm itself means systematically. So there is an algorithm that will do a job for us that is called Gaussian elimination. So basically whatever we have just seen is a small part of Gaussian elimination, but this Gaussian elimination does not care how many equations you have. You have 1000 equations, 10,000, 10 billion, 10 million, doesn't matter. There is a systematic procedure using which you can do it. Okay, that is called Gaussian elimination. That will help us to solve system of linear equation. That's very, very powerful method. Let's just see that what it requires. So this method requires like a few of the terminologies to understand. For example, like first of all, this method convert a matrix. This is a Gaussian elimination method which convert a matrix to a echelon form of the matrix. So what is the echelon form and how to convert? These are the some questions that we need to answer yet, right? So this method basically requires few of the basic terminology to understand, which is echelon form of the matrix, and I think pivot and free variables, elementary row operations, and row reduction echelon form. This is one optional thing that we will do at the end. Okay. But yeah, this requires these three basic things to understand. Then you will get to know that what is Gaussian elimination. So let's just first understand what is the echelon form, because this Gaussian elimination is doing nothing but converting a matrix to an echelon form of the matrix. Actually, this echelon form is just a better way to visualize the matrix. That's all. Which means that given a matrix, if you have the echelon form, you can visualize it in the better way. So using the Gaussian elimination, we will convert that given matrix to the echelon form of the matrix, and you will require 2 or 3 things to know before that, like echelon form, what is the echelon form, what are the pivot variables, what are the elementary row operations, and so on, right? So let's just understand that what is the echelon form. Basically, our objective is to convert a matrix to echelon form. But before that, we first have to understand what is the echelon form, and then we will move further. Okay. So what is the echelon form? What are the pivot variables? What are the elementary row operations? Let's just understand. So echelon form is also called row echelon form. So just see here that what is written. In this form, I mean, this is just a matrix. We say a matrix is an echelon form if all non-zero rows are above any row of all zeros. Okay. Which means that if you have any non-zero row, let's suppose this row is non-zero, then this row should be above all zero rows, which means zero row should be below this only. It cannot be the case that zero row is here and non-zero row is here. It cannot be the case. All entries in a column belong below the leading entry are zero. Okay, so which means all entries in a column below a leading entry, which means that let's suppose this is the leading entry. I will give you the example. Let's suppose this is a leading entry, and below all of this should be zero. That's what they are saying. The leading entry of any row occurs to the right of leading entry of any other row. Okay, any other row that is above it. So I will tell you that what does these three statements means. Let me just give the example. Okay, so examples of the echelon form. Now you see that this is one leading entry. Leading entry means this is one entry which is the first non-zero entry of this row. This is leading entry here. I'm just circling out the leading entry. This is leading entry of this row, and this is leading entry of this row. So these are the 3 leading entries. Similarly here, this is the leading entry of this row, this is the leading entry of this row, this is the leading entry of this row, and here there is no leading entry in the last row because all elements are 0. So first, like I'm just circling out the leading entry, and from here you can immediately check whether it is in echelon form or not. How? Let's just see why the statements first. They are saying that all the leading entries should be having 0 below, which means if this is the leading entry, just check which is having is this having the 0 below. Yes, this is 0, this is 0. There is nothing here, so that's not an issue. Okay, this is 0, this is 0, this is 0. Yes, so all the leading entries are having zeros. That's for sure. Now let's just see the second thing. So they are saying that all entries in the column below the leading entries are 0. So that's what we have just checked. All non-zero are above the zeros, which means if this is non-zero, isn't it above the 0? Yes. So all non-zero rows, which are the 3 rows, are above the 0 row, which is also true in this case. And the third thing is that the leading entry of any row occurs to the right of the leading entry of the row above, which means if this is leading entry, then it is the right, okay, of any row. Let's suppose leading entry of this row occurs to the right of the leading entry of the above row, which means that if this is the leading entry of the above row, which means this 5 is a leading entry of the above row of this 1, then this 1 should be occurring on the right hand side. Similarly, this -6 should be occurring on the right hand side of this one. Okay, so these are the 3 conditions. But there is a good news. Good news is that you don't need to worry about these 3 conditions again and again. You can immediately check by just circling out the leading entry. Once you circle out the leading entry, that is also called the pivot element. I will tell you about it. Okay, but once you circle out the leading entry, what you can do, you can just check whether it is forming stairs or not. Just check whether it is forming stairs. Since it is forming stairs, you will say that it is in echelon form. See, this is the stairs, right? This is the stairs. I will tell you that where is not a stair. So I will tell you. Don't worry. Just see here. These are the examples which are not in the echelon form. Why? Because this is leading entry. Okay, I'm just circling out the leading entry. This is also leading entry. Now just try to form a stair using the leading entries. This is the leading entry. You will go down only when you find the non-zero. So since there is you cannot go down if you want to connect these 2 leading entries, then you can see there is a jump, right? Jump is not possible. So there should be step by step stair, something like this, right? Step by step stair. So now because the zero row is in the between, that's the problem. Now you just check here. This is okay, leading entry, this is leading entry, this is leading entry. Now let's just see if they are forming the steps or not. So stairs or not. So that is fine, that is fine. But if you want to go to this leading entry, you will go something like this, which is not the stairs, right? You should be going something like this, something like this. So if it is not stairs, it is not in echelon form. That's why this is not in echelon form, this is not in echelon form. So you just check the stairs using the leading entry. See, let's suppose this star are the leading entry. Leading entry means the non-zero entry. Okay. Let's suppose these are the non-zero entry. The stars are non-zero. Non-zero, and these dots could be 0, could be non-zero. Actually, I don't know. Like that's why I'm writing dot. It could be 0, it could be 5, could be 3, could be 2, could be anything. Okay, these dots could be anything. But I'm just interested in the first entry. After that, what happens? I don't care. Maybe 0, maybe non-zero. So if you just check, it is forming a stairs, right? And then ultimately after that all are 0. That's fine. Cool. So this is in the echelon form. Now let me go to that page. Yeah. Now let's just see if this is the echelon form. Like I'm not giving the absolute value. I'm just telling you that if you are forming the stairs, then it is in the echelon form. Okay. Now let's just do this question. What are the matrices which are in the echelon form? Let's suppose these are the non-zero. These are the leading entries which are non-zero. So is this in the echelon form? Seems that, right? It is in the echelon form. It is in the echelon form. What about this? I don't think it is in echelon form. Why? Because if you connect the leading entries, then you are not able to connect using the steps. And because this 0 row is in the between. So that's not in the echelon form. What about this? What do you think? No, right? Because this is not the stairs. Because if you connect, then these are not the stairs that you are getting. So that's why this is not in the echelon form. What about this? You go to this leading entry. Yes, this is the echelon form. So this is the echelon form. This is the echelon form. But these 2 are not in the echelon form. Let's just go to the next question. Which matrices are in the echelon form? Just tell me out of these 2, which matrices are in the echelon form. So this is a leading entry. This is a leading entry. So here, if you just try to connect these 2, then you will not be able to connect using the stairs. So that's why this is not in the echelon form. What about this? This is a leading entry. This is a leading entry. You cannot again connect these 2 using the echelon form. So that's why this is also not in the echelon form. Using the steps you cannot connect. So that's why this is not in the echelon form. So I hope now you understood that what is echelon form and what is not echelon form, right? That's a very basic definition. Now let's just try to understand what are the pivot and free variables. Basically, there is nothing special in this. If there is something in the echelon form, let's suppose this is the echelon form, then I will talk about pivot and free variables. So this leading entry variable is called pivot column or pivot variable. These are the pivot column or pivot variable. Why I am calling this as a variable, even though these are the columns, you will get to know. You know that this Ax equal to B can be represented in the matrix form, right? So basically, I will tell you that why we are calling these things as a variable, although these are pivot. Although these are the columns. So this is the pivot variable or the pivot column. For now, let's just say this is the pivot variable or the pivot column. So basically the first non-zero entry is called in the echelon form. Okay, in the echelon form, it has to be in the echelon form. If it is not in the echelon form, then I don't define the pivot or the free variables here. Okay, so if this is echelon form, then I will say that okay, this is the pivot, this is the pivot, and remaining columns, see this column, so you will say this these are the pivot columns. Actually these two are the pivot columns. Okay, these two are the pivot columns. Remaining columns, I say these are the free columns. Okay, we say that these are the free columns if these are not the pivot column. So if you just go by the definition in row echelon form, that's very important that this thing is defined just for the row echelon form. It is not that you can define it for anything. Okay, so this thing is defined just for the row echelon form. That is very important to understand. In row echelon form, a variable whose coefficient is a leading non-zero is called a pivot variable. So in row echelon form, this is the row echelon form, a leading non-zero is called pivot variable. That's the only definition. Otherwise, the variable is known as a free variable. Actually, you call it variable or call it column, both are same. I will tell you why. Okay, so variable or the column, both are same basically. Actually, every variable represents a column. In this ax equal to b. So let me tell you what do I mean by that. Maybe I can just quickly tell you. Let's suppose you are writing 2x plus 3 equal to 5, 2x plus 3y equal to 5, and then let's suppose 3x minus 2y equal to 9, something like this. And then what you do, you make a matrix out of this, right? You say this is 2, this is 3, this is 3, this is minus 2. And sometimes we also write this 5 and 9. This is called the coefficient matrix, and the complete thing is called augmented matrix. I will tell you about this augmented matrix, but if you are not comfortable, let's just keep this 5 and 9 away. And then let's just talk about this matrix. So now, as you notice, this 2 and 3 are the coefficients related to x. So we say that this particular column is dedicated to x, this particular column is dedicated to y. Since these are two columns, two variables, so we say that each column is just, this is an interchangeably term that you say that this is a pivot variable, or you say it's a pivot column. Generally we call this a column. You say that this is a pivot column. The complete column is a pivot column, or you say that x is a pivot variable, right? Because each column, there is a one-to-one correspondence between the column and the variable, because this first column and this second column are respectively for x and y, right? Are respectively for x and y. So we say that this first column is dedicated for x, the second column dedicated for a variable y. So that is why you say either this is the first column or the first variable. Doesn't matter basically. Okay, so this is the first column, or you say or first variable. So basically both are we will using both interchangeably. Now let's see this question. What are the basic? Okay, basic and pivot, again both are same. Sorry for this terminology, because I have not defined it, but that's the way it is. Okay, so some people call it basic variables, some people call it pivot variables. Okay, basic variable is basically, basic is a term that is associated with the variable, and pivot is a term that is generally associated with the column. We say pivot column. If you want to say variable, we say basic variable. Anyway, we will be using them interchangeably, which means either I can say basic variable or I can say basic column. Similarly, I can say pivot variable or I can say pivot column, or just like this. So basically there are two terms, pivot and basic, and again there are two terms which are which you can say the columns and the variable. So generally we say pivot column or we say basic variable. Both are same, but yeah, we say pivot column or basic variable. But I don't want you to confuse, or I don't want you to even remember that okay, the pivot term is associated with the column. So that's why I will say pivot. I may say pivot variable, I may say pivot column. Actually, it doesn't matter for us. Okay, so I hope you understand. Cool. Now let me put that on the side because it's not much relevant to us. Now they are saying that what are the basic variables and what are the free variables in the augmented matrix. Now just see one thing, they are asking about the augmented matrix. See, I gave you the example. In this example, this is called coefficient matrix, where you just have the coefficients. But if you also have the RHS, then we call it augmented matrix. So for example, here the augmented matrix will look like this. This will be the coefficient matrix along with the RHS. So here just by this line. This is just a separation line. If you want, you can write it. Otherwise, there is optional. I mean, if you want, you do not need to write it. It is just for our sake of understanding. Otherwise, whenever you are representing that in computer, you want to be drawing a line, right? Okay. So this is called augmented matrix. Augmented matrix. What is the difference here? There is you have coefficient matrix, which is A, and then you have your right hand side vector, which is B, which means I can say that this A is just your coefficient matrix, and if you have A along with B, which means if you have this A, here you have A along with this B, then this is called augmented matrix. This is just one terminology that I wanted to introduce. Now in augmented matrix, if they ask you the basic variable or the pivot variable or the basic column or the pivot column, then in that case you do not consider this column. This column is not belonging to any variable. Just see here. See, this is belonging to X, this is belonging to Y, but this does not belong to anything, right? Similarly, for example, let's suppose I have three set of equation, 3x plus 2y minus z equal to 5, 2x minus 3y plus 5z equal to 17, and let's suppose this is 3x or maybe 5x or anything, 9x plus let's suppose 7y minus 3z equal to let's suppose 12. Let's suppose these are the set of equation that you have. Now you need to write the augmented matrix here, suppose. Okay, then what you will do? You will just write the augmented matrix in very simple way. You will be saying that you can write the coefficient matrix 3, 2, 9, and then 2 minus 3 and then 7, and this is minus 1, 5, and then minus 3, and then you have the right hand side, which is 5, 17, and then 12. Now this is called augmented matrix. This complete thing is called augmented matrix. Now just notice here is that this particular column is belonging to X, this particular column is belonging to Y, this particular column is belonging to Z, but this particular column does not belong to any particular variable. So that is why we do not associate or we do not say that this particular column is a free column or a pivot or the basic column or the pivot column, right? So we do not associate any number here, any term here, free or pivot, we do not associate. So if they're asking you about the free variable or the basic variable in the matrix, then if this is augmented matrix, then you do not label the last column. This is my point. Okay, don't label the last column. Why? Because this is the augmented matrix. Since it is augmented matrix, you do not need to worry about this. Now just check here what are the free and basic or the pivot column. So see, this is non-zero entry, this is non-zero entry. So you can say this is the pivot, and here you do not have the leading non-zero. Here it is actually 0, so this is not the pivot, and then remaining are basic, right? Sorry, remaining are free. So this is free, and what about this? This is neither free nor pivot. I mean, this is like you do not associate anything here, because this is not corresponding to any variable, right? This is not corresponding to any variable. So you do not generally say that this is a pivot column or the free column. You do not say this. Here, this is the pivot column, this is the pivot column. Both are the pivot columns, right? So you will say this is pivot and this is pivot. I hope you understood the answer. Now let's just solve one more question. Here they're asking what are the free or the basic variables in the given augmented matrix, right? So again, you do not need to consider this. Then just answer this question. Because of the augmented word, you do not need to consider this. Now just answer this question. Here you will say this is pivot, this is pivot column, this is again pivot column, and this is not the pivot column. So these three columns are the pivot column. This is pivot, this is pivot, this is pivot, and this column is basically a free column. Okay, so that's how you can find out pivot column and free column. Actually, like why we are doing all of this, you will get to know. I mean, basically this free column is a linearly dependent column on the pivot columns. So I can guarantee you that there always exist a linear combination of these pivot columns, such that you get this free column. There is always this case. Okay, so anyway, we will talk about this in more detail later. Here, this is the pivot column. This is the pivot column. This is the free column. In between, this is the free column. So you just check. This is pivot. This is pivot. This is free. Can you represent this free column as a linear combination of the pivot columns? I think yes. You can just say that 2 times of this you are getting this, right? So that's very easy. Can you represent here this free column as a linear combination of pivot column? This is 0, 1. I think maybe, yeah, 1 time of this, maybe 1 time of this minus 2 times of this, and then 0 times of this, right? So let's suppose this is C1, C2, and then this is C3, then this is C4. You can say C3 equal to C2 minus 2 times of C1. I think that's it, right? And then plus 0 times of C4. So using this equation, you can get this C3, but you don't need to worry about it. Like how to find this coefficient and why we are doing all of this. You don't need to worry about it. I will tell you that how to find this coefficient and all. But if you want, you can just remember now. Otherwise, like we will see it later, that this free column, okay, free column is always, let me just write it on the next page, that free column is always linearly dependent on pivot columns. Okay, which means you can always write the free column. You can always write the free column as a linear combination of pivot columns, right? As a linear combination of pivot columns. So these are the pivot columns. Okay, this is my point. Now here they are saying mark free and pivot columns in the given echelon form. Then you can just check. This is first non-zero. Again, this is first non-zero. This is the first non-zero here. So again, they are saying about the augmented matrix. So that's why let's not worry about this column. So they are saying that just mark it. So this is pivot. This is again pivot column. This is again pivot column. These all are free columns, right? This is free. This is free. Rest are free columns. That's very easy. You can do it. Okay, mark free and pivot columns in the given echelon form. So in some augmented matrix. So again, this is augmented matrix, so you do not need to worry about it. And then you can say that this is pivot, 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 and rest are free columns, right? So this is free column, this is free column, this is again free column. These two are free. Okay. So in the next video, we will see something called as elementary row operations, and then we will go to the rank. So like this is very important operation that will convert any matrix to a echelon form, and that is called the Gaussian elimination. So let's just cover this particular topic in the next video. In this particular video, we have just gone through the few definitions, that what is the free column, what is the pivot column, and then also we have talked about what is an echelon form, right? So this is the basic definition video. Now these two are covered. Now let's just see this in the next video. Okay, thank you.